Alright, let's talk about something that might sound intimidating at first, but actually makes the weird world of atoms and molecules way more approachable: density functional theory, or DFT. If you've ever wondered how scientists can predict the behavior of materials, design new medicines, or even create better batteries without stepping foot into a lab, DFT is a huge part of that magic. Here's the deal. At the heart of everything around us, your phone, your favorite snack, the air you breathe, are electrons. These teeny tiny particles zoom around atoms and basically hold all of matter together. But trying to figure out what each individual electron is doing? Yeah, that's like trying to track every bee in a gigantic buzzing swarm. Not gonna happen. This is where DFT steps in with a clever shortcut. Instead of following each electron, it looks at the whole swarm, where the bees or electrons tend to cluster and where they don't. Scientists call this the electron density. Imagine you're looking at a heat map, and you can see which parts are hot with electrons and which are cool. That picture actually tells us a ton about the system. Now, here's the wild part. DFT uses that electron density map to figure out the energy of the whole system, how the atoms are behaving, and even how they might change if you poke them. It's like knowing the mood of a party just by seeing where people are clustered, instead of interviewing every single guest. This idea, simple on the surface but super deep underneath, lets scientists predict how molecules will interact, how materials will conduct electricity, and how chemical reactions might unfold, all on a computer. Sometimes, DFT even points the way before anyone mixes chemicals in a beaker or fires up a fancy microscope. Think about it, the pigments lighting up your phone screen? DFT helped figure out how those molecules would behave. The drugs in your medicine cabinet? DFT likely played a role in predicting how those molecules would bind and work. It's woven into the fabric of modern science and tech, even if you've never heard its name before. Of course, DFT isn't perfect. No model is. But it's always improving, helping scientists push boundaries in physics, chemistry, biology, materials science, and engineering. With every tweak, it gets us closer to designing new materials, understanding complex reactions, and inventing things that just might change the world. So the next time you hear about a breakthrough material, a new drug, or some wild scientific discovery, there's a good chance density functional theory was buzzing in the background, quietly mapping out the hidden world of electrons, all from paying attention to where those electrons like to hang out. Thanks for joining me on this quick dive into the magic of DFT. If you want more science made simple, stick around. I've got plenty more to unpack.